Hello everyone, welcome to today's presentation on serverless computing and function as a service, or we also called it as FaaS. So, serverless computing is transforming the way applications are built and deployed by allowing developers to focus solely on code while the cloud provider manages the infrastructure. In serverless computing, there's no need to worry about server scaling or capacity planning. It's all handled behind the scenes. Now moving towards the what is serverless computing. Let's dive deeper into what makes serverless computing unique. First, completely eliminates server management. The cloud provider handles server provisioning, maintenance, and scaling. Next, serverless environments are event-driven and can automatically scale up or down based on demand. Lastly, it's pay per use, meaning you are only charged when your code is actually running, avoiding costs or idle resources. Now, moving towards the benefits of serverless and FaaS. So, now let's see what are the benefits of serverless and FaaS. FaaS offers several distinct advantages. First is cost effective, as you only pay for each execution. Second, because FaaS functions scale automatically, developers don't need to predict traffic or manually adjust resources. And third, it simplifies operations, removing the need to handle server directly and allowing teams to focus solely on developing the code. Now moving to the next slide, which is scaling automatically with serverless. So for first is event trigger. So function is invoked by an event such as an HTTP request or database event. And second, instance creation. The cloud provider instantly creates new function instances to handle concurrent requests. And the last one is auto scaling. Or more so for more instances are added as demand increases. Unused instances are removed. Now moving to the another slide, which is cost efficiency or serverless computing. One of the attractive feature of serverless computing is cost efficiency. So for first point is no ideal cost. So pay only when your code runs. Eliminate cost for unused server capacity. Precise billing. Charges are based on execution time and resources used, often billing billed in milliseconds. The third, reduced operational cost. No need for dedicating DevOps team. Lower cost for server management and scaling. Now, there are some platform which provide serverless functions. One of them is AWS Lambda. This supports multiple languages such as Node.js, Python, Go, Java. Developers and organization can choose as per their requirement, and they provide execution time limited to 15 minutes, ideal for short running tasks. AWS integration seamlessly integrate with other AWS services, easy to build complex serverless applications. Now, moving towards the another slide. Google Cloud Functions are also one of the serverless functions or platforms, we can say, which supports Node.js, Python, Go, Java. Maximum execution time is 9 minutes. Key features are event-driven, automatic scaling, and pay-per-use. Integration is can be easy. Google Cloud Services third-party APIs. Moving towards the another slide. So we also have Microsoft Azure functions. So first, create function. Write function code in your preferred language such as C Sharp, JavaScript, Python, and more supported languages. Set trigger, define event trigger, HTTP request timer, or Azure service events. And third one is deploy. Push to Azure. Function is immediately available to scale automatically. Now, another slide is here. Let's see some real world applications of serverless computing. So, where is FaaS being used? There are many applications. For example, social media platform use FaaS or serverless applications. to process image uploads or send notifications. In e-commerce, FaaS can handle order processing during high traffic sales event. And in IoT, FaaS function can quickly process large volume of data coming from devices, making it ideal for runtime application. There are many real-world applications for serverless or fast cloud computing. Now moving towards the another slide. Now let's see how fast differ from traditional server models. So we will let's see by point. So first point is infrastructure management. So in fast function as a service, uh, fully managed by the cloud provider, developers focus only on writing code. And in traditional server model requires manual setup and maintenance by developers or IT team. Now, another aspect is resource allocation. Dynamically allocated resources are provisioned by per function execution. In traditional server models, fixed resources based on server configurations. Now, deployment unit, individual functions, each serving a specific purpose. In traditional server model, complete applications or services deploy as a package. Now, another point is execution time. So, in function as a service, limited execution time per function. Example, AWS Lambda, 15-minute limit. And in traditional server model, can run continuously with no time limit as long as the server is up. Now, another point is cold starts. So, in function as a service, often has a cold start delay when invoked after being ideal. In traditional server model, no cold start delay. Server is always running, it keep active. Now, another aspect is state management. So, in function as a service, stateless by nature, each function invocation is independent. In traditional server model, can be stateful. Server maintain state throughout sessions. Now, another point is development focus. So, serve function as a service focus on individual event-driven functions, and traditional server models focus on complete applications which with complex server-side configurations. Now the last point is monitoring and debugging. So, in function as a service, more challenging due to disturbed nature. Specialized tools are needed, and in traditional server model, easier to implement within a single application environment. Now let's move to the another slide, which is challenges and considerations, limitations for serverless. However, there are few challenges with FaaS, such as cold start, limited execution time, vendor lock-in, debugging complexity. So let's see first cold start, which happens when a function has not been used for a while, can add a slight delay, which might impact application with low latency requirements. There are also a maximum execution time for instance. AWS Lambda has 15-minute cap, which means a long-running task may not be suitable for fast. And the third is vendor lock-in is another consideration, as each cloud provider has its own fast platform, making migration between platform more complex. And the last one is debugging complexity. Distributed nature of serverless can make debugging more difficult. Robust monitoring is crucial. Now, moving to the next slide. So we are coming to conclusion. So in conclusion, serverless computing and function as a server service offers a flexible, scalable, and cost-effective way to build applications in the cloud. While shifting infrastructure management to the cloud provider, FAST allows developers to focus on cloud coding and innovation. Despite a few limitations, the benefit make it an attractive model for modern applications, specifically for workloads that are event-driven or variable in demand. So now we will see some MCQ questions based on serverless computing and function as a service. So first question is, what is the primary characteristics of function as a service? So we have four options. Option A, it requires developers to manage server. Option B, it is a serverless architecture focused on running functions. Option C, it can only be used for web applications. Option D, it requires manual scaling of resources. So our correct answer is option B, which is it is a serverless architecture focused on running functions. Now, this another question two is which of the following is not an example of a FaaS platform? So option A is AWS Lambda, option B Google Cloud Functions, option C Azure Functions, option D Apache Hadoop. As we already seen some FaaS platform, so we all know the correct answer is D, Apache Hadoop. Now, the third question is what is a key benefit of using FaaS? So option A, high operation cost. Option B, the need for complex server management. Option C, pay per use pricing model. Option C, manual scaling requirement. So our correct option is C, pay per use pricing model. Now, question 4 is which of the following best describes a cold start in FaaS? So option A, the delay when a function is first invoked after being inactive. Option B, the initialization of a server for a function. Option C, a server failing to start. And option D, high latency during peak model. So our correct answer is option A, the delay when a function is first invoked after being inactive. Now the fifth question is in FaaS, how is scaling typically handled? So for this, our option A is manually by the developer. Option B, automatically by the cloud provider. Option C, based on defined schedules. And option D, not applicable to FaaS. So our correct option is B, automatically by the cloud provider, as we previously seen this. So now moving to this question 6, which of these is a real world application of FaaS? So option A, running a static website. Option B, performing data batch processing. Option C, hosting a database. Option D, running a virtual machine. So our correct option is B, performing data batch processing. Now question 7 is what is one common challenge associated with FaaS? So option A, unlimited execution time. Option B, complex server configuration. Option C, debugging and monitoring functions. Option D, lack of any scaling capabilities. So our correct option is option C, debugging and monitoring functions. Now the question 8 is which cloud provider offer Azure functions as its FaaS platform? So option A, Amazon Web Services. Option B, Cloud, Google Cloud Platform. Option C, Microsoft Azure. Option D, IBM Cloud. So our correct answer is option C, Microsoft Azure. Now, the ninth question is which pricing model is typically for FaaS server services? Option A, monthly subscription. Option B, pay per function invocation. Option C, flat rate per GB used. Option D, hourly VM charges. Our correct option is B, pay per function invocation. Now, the last question is what is the one method to reduce the impact of cold start in FaaS? So option A, increasing memory allocation. Option B, using pre-warmed instances. Option C, reducing function size. Option D, turning off auto scaling. So our correct option is using pre-warmed instances. Thank you for watching this video, guys.